Okay. Hi, everyone. Welcome to the first ever Women in Mina workshop. We're so thrilled that you guys are here, and we're so excited to be starting a community of women and non-binary developers interested in zero knowledge. We had almost like 100 signups, so it's really exciting to see everyone here. Hey, everyone who's joining. My name's Regina. I do developer relations at Oman Labs, which is a company that is one of the ecosystem partners of Mina Protocol. One of the things that we're working on is we're building the technology and tools needed to write zero knowledge apps on Mina. We also have here Alysia, who's joining as a co-host in the workshop. Alysia, would you like to introduce yourself and tell a little bit about your backstory of how you ended up becoming part of the Mina community and a zkApp developer?
Sure, nice quick story time then. So I'm a freelance Web3 developer. I also create content teaching developers how to build in Web3. So you can find me on all social media, including Lens Protocol, which is Web3 social media. And I got started in Web3 in 2018. I was working as a data engineer at the time, and then someone headhunted me to do a role at Consensus. But I didn't want to switch from data engineering just yet. So I ended up working for a company called Elliptic. And I was a blockchain data engineer there. And what we did was literally traced all the good actors and bad actors in the blockchain. So we were checking multiple blockchains and seeing who were doing illicit activity and also positive activity. And so that obviously got me very familiar with blockchain nodes and how large a blockchain node can be. So for example, if you want to sync the Ethereum blockchain, that's 1 terabyte of disk space that you need. So when I learned about Mina and the fact that you can have a blockchain size that's constant, I was very much intrigued. At the time, I had no idea what a zk proof was. And it's really fascinating to me that the zk proof topic is a hot topic right now because I studied computer science, never heard about it one day in my life. But now everyone is talking about zk proofs. So then I started learning more about it, and I learned about the fact that you can create privacy applications on the zk blockchain. And then I came across a builders program from Mina. I saw an email from them and they said, oh, we have a builders program teaching you how to build zkApps. So I signed up. That was late last year. And through that program, I learned how to build a zkApp, surprisingly easier than I thought. I also did a hackathon on the Mina blockchain as well. I have YouTube videos talking about that too, if you guys want to check it out. But yeah, that's me.
Thanks for the intro. Yes, all of you should check out her YouTube channel. There's a ton of fun zk videos actually on there, and other videos related to blockchain stuff. Cool. So today's workshop, the goal is we're going to be building a simple zero knowledge smart contract on Mina Protocol. Along the way, we'll learn a little bit more about how zk programming works and some useful tools and libraries for writing zk programs. And for this workshop, it's ideally for someone who's like new to Mina or new to zk programming. You don't have to have any like background or prior experience with writing smart contracts. But if you're familiar with JavaScript or TypeScript, you should be fine. Hi, everyone who's just joining. And this is our agenda for today. We're going to go through intros and a quick icebreaker. Then we'll talk about Mina Protocol, SnarkyJS, and zkApps. We'll also talk about a real-world use case for zero-knowledge apps. And then the majority of the hour will be spent building a simple zkApp. And then also Q&A at the end. All right, let's break into intros and icebreakers. Since we have a small group, actually, no, it's not big enough. Since we don't have, we have a kind of medium-sized group size, we're going to ask everyone to post in the chat your name, your occupation or background, where you're from, if you're comfortable sharing that, and this fun icebreaker question. Let's see, would you like to share the icebreaker question that I came up with, but I'm making you ask everyone?
Sure. So guys, we are going to have a picnic because it's sunny outside, it's springtime, and we're going to bring food, game, utensils. So what would you want to bring if you were coming to this picnic? And I guess I can start first. I would bring fruits, to be honest, because I'm vegan and people do not think about me at picnics. So I will be bringing fruits to make sure that I am fed.
That's a really good one.
Jennifer, what would you bring?
Just put it on the spot. Wait, Kate, you wrote something. Why don't you share what you would bring and why?
Yeah, my voice isn't the best. I'm so sorry. I'm recovering from like a really horrible, like triple crown of cold. But I always bring napkins to every picnic because it's one of those things that everybody packs up food, they pack up wine or soda or something, but they always, almost everybody forgets napkins, and they are so important, especially if they're cloth napkins. That way we're not ruining the environment, adding to the trash, all of that, and they can just easily be washed afterwards. So, yep.
Agree. Love napkins are important, especially cloth ones. Let's see. Tina, would you like to share what you would bring?
It's me, right?
Hello.
Regina, yeah, hi, everyone. I'm Tina. I am the Asian marketing lead, and I guess I will bring the same with fruits because I am a fruit lover. And then I like watermelon if it's in the season. Yeah.
I love that. Sounds like we'll have a lot of fruit and napkins. Jennifer, what would you bring?
I was gonna say watermelon too, but since you said that, maybe some fun like drinks to share, like juice or sparkling water or something.
That sounds awesome. Okay, we have like drinks, we have drink set, we have fruits, and we have napkins. Janae, how about you? I see you thinking.
I was thinking, I was like, okay, if we have the drinks, we have the napkins, we need something to really eat, right? So I was like, maybe some sandwiches. I love a good Sammy, so we can have some sandwiches, some chips. But also, honestly, if this was a real picnic, I would be bringing the white wine. Just gonna say.
Perfect. We could combine the wine with the fruit, make sangrias. Is that how you make sangrias? Awesome. Cool. Yeah, I can't wait to read through all these responses. If you have any other ideas for picnic items, put it in, and yeah, just be fun. All right. Let's move on to our workshop. Now I'm going to talk about Mina, SnarkyJS, and zkApps. Also, if you have any questions throughout, like this part is going to be a lot more like presentation style. So if you have any questions about something that I mentioned, feel free to post it in the chat. Alysia will be there, and lots of members from Mina Foundation 01 who can help answer, or members of the community. If you know the answer to a question, feel free to jump in and help out. But yeah. So what is Mina? Mina is a layer 1 blockchain built on zero-knowledge proofs. It was created in 2017 and launched its mainnet network in 2021. What's really cool about Mina is that it uses recursive zero-knowledge proofs to verify its consensus state. So exactly how does that work? So there is a type of zero-knowledge proof called zkSnarks. It stands for zero-knowledge distinct, non-interactive arguments of knowledge. That's a long word. I just say zkSnarks. But Mina uses zkSnarks as its proof architecture and has developed its own type of zkSnark called Pickles, which supports this concept of recursion. So basically what's happening on Mina is that we're using a proof that can refer to itself. And because of that, no matter how big the proof, or no matter how far in the future, the proof can refer to itself, and the size of the proof can stay the same no matter what. And so what that means is, while other blockchains are growing in size, they're over like 400 gigabytes or bigger, Mina, thanks to zkSnarks, thanks to recursion, can stay at a fixed size of 22 kilobytes. And thanks to zk, not only is Mina able to maintain a small, succinct blockchain size, it also has resulted in a bunch of other cool things, such as oracles, a bridge to Ethereum, and what we'll be talking about, zkApps. So what are zkApps? zkApps are smart contracts powered by zero-knowledge proofs. They use an off-chain execution and mostly off-chain state model. And the best way to understand what that means is to first look at Ethereum. So on Ethereum, all the computations are run on-chain and uses a gas-based fee model. And so each time a user wants to interact with a smart contract, what will happen is they'll need to send instructions to Ethereum, and every node across the network will need to execute that same transaction. So basically, when you're interacting with smart contracts on Ethereum, it gets really expensive, it gets time consuming. It is not the most ideal place if you have a very complicated program. Mina, on the other hand, uses off-chain computation. So whenever a user is like working with a smart contract, all that is happening on the user's computer browser, off the whole blockchain. And the only thing that the user is sending to the Mina network is a small proof and some state updates. So as a result, that all Mina serves at is like a checker, checking to see if the proof is valid. If it is valid, it'll update some state on chain. If the proof is not valid, it'll just reject it and nothing will happen. So as a result, there's no need to execute a full program across all the nodes like on Ethereum. With Mina, we're just checking the proofs. And so that makes working with smart contracts on Mina really fast and super efficient. So just in summary, the reason why zkApps are awesome is that one, it keeps the blockchain succinct and scalable. It also helps contribute to privacy. Users can keep some of their data private and off-chain. It's also super efficient because all computations cost the same, and they also take the same amount of time. So how does zkApps work exactly? So the best way for me to think about it is kind of run through the user experience. And here's like a rough diagram of how a user would interact with a zkApp. So here's an example program where it checks to see if a user is older than 18. So here the user submits a birthday, some January something, 1989 or something. They'll send it to a website, and the zkApp will check if the user is 18 and older. If the user is 18 and older, it would generate a proof and then send this proof in a transaction to the Mina blockchain. And then this Mina will check to see if the proof is valid. If it is, it'll accept the transaction. If it's not valid, it'll reject the transaction. And if it turns out the user is under 18, nothing will happen, no proof will be generated. So this is kind of like the flow of what is going on behind the scene, very high level. If you have any questions, again, please post in the chat. So you might, if you didn't catch it in the last slide, I mentioned that there's like a website involved. And so that's because zkApps are actually two parts. It is both a smart contract and a UI, and both parts are necessary for a zkApp to exist. The smart contract acts as the logic, and the UI or website acts as how a user would interact with a smart contract. And also, just for FYI, the website is what generates the proof that's being sent to the Mina blockchain. So how do you write a zkApp? Like the idea of zk can be very math heavy. It would seem like writing a zkApp would be very complicated too, right? That's why we created the zkApp CLI. The CLI is a tool that we've created that makes it super easy to write zk smart contracts. It comes with project scaffolding. It uses all the existing technologies that most people are familiar with, such as TypeScript, NPM, ESLint. It also includes SnarkyJS, which is a TypeScript library that makes it easy for us to write smart contracts based on zero-knowledge proofs. So SnarkyJS, as I mentioned, is a library, and it enables you to basically work and write zk circuits and smart contract in a language that you're familiar with, TypeScript. And it also makes it possible for your website to be, your smart contract to be accessible by the website. So just in general, yeah, SnarkyJS takes out all the complicated parts of working with writing zk so that you can focus on writing your smart contract. So with that in mind, I'll show you the developer experience, and maybe they'll give you like a sense of like how writing or what writing a zkApp would look like. So one, the developer would create a zkApp project, and then you would write the code for the smart contract. Once you deploy it, thanks to the CLI, it'll generate two things. One, it'll generate the smart contract file, which will integrate with the website. And it'll also generate a verification key, which will be sent to a Mina address on the Mina blockchain. And this address will serve as like the place where all future transactions related to your smart contract will go. And this is what checks, if a proof is valid or not. So I kind of went through really quickly, what is Mina, what is zkApps, what's SnarkyJS. Now we'll kind of like break away from that topic a little bit, and Alysia will share a use case that you can use for zero knowledge.
Sure. So this happened in real life. This is the receipts to prove it. So basically, I was trying to rent an apartment last year. Okay, cool. Found someone online, big agency, checked the reviews, all seemed good. But within like about 10 minutes of speaking, I was asking, okay, how, what's the security deposit and stuff like that? And then he asked me to share my passport and visa to be able to just get simple answers. And I asked him, why do I need to share this information? I am just asking you about the details about renting this apartment. And he sent me a voice note later stating that, oh, we just want to prove to the landlord that you're a serious tenant and you really want to get the property. And I said, and he was like, why don't you want to share it? And I'm like, well, if I share with you my passport, you now have my passport number, you have my date of birth, like you have these identifiers about me that you don't need to know in order to verify my name or even my nationality. And he said, well, oh, we just want to show the landlord that you're serious and, whatever. And I had not seen the property just yet. I literally just found him online. So of course I didn't go ahead with him. Now, let's say he was actually a valid real estate agent. Let's say this is a valid practice. Then he was just trying to verify that I'm a real person. So he was trying to prevent that he was getting scammed. I was trying to prevent that I was getting scammed as well by giving my personal details. So the way that a zk proof could be used here is that if there was an application that was created that did indeed allow me to submit some document, for example, a passport, but encrypted, and it can check to see that my name is actually Alysia, which is what I'm stating in the application, then he will be able to trust via the zkApp that I am indeed Alysia and my nationality is indeed X. And I will be able to trust the fact that he has this detail that he wants about me, but he doesn't have all this personal identifying data that he can potentially use to steal my identity in the future. So I thought that this was interesting. And PS, I spoke to another agent about this and she was like, this is not typical practice. She has never heard of that. So I probably did dodge a scammer. But I don't know. So, but you know what I mean? Like, and the property that he had was so nice. I really wanted it. So I had incentive to give him the details. But of course, I'm trying to be safe in these streets. If this was a zkApp, we would have no problems. I'd be up in a nice penthouse, but here we are.
Interesting. Sounds very, I hope you found a place since then.
I did.
Cool. Awesome. Yeah. Correction. Yeah. If a realtor is asking for a passport, like, stay away. Thank you for sharing. Yeah. If you have any use cases that you want to discuss or talk about, we can also talk about at the end during the Q&A. But yeah, this is definitely something that we all need eventually or soon or right now. All right. Let's move into the live coding part of our workshop. So if everyone has their terminals or computers ready, now is the time to get that all set up. This workshop or this part of what we're doing is all based off tutorial number 1. So I recommend everyone go to this link here. You might need to go to docs.minaprotocol.com and find this tutorial called Hello World. I highly recommend you open that up because we'll be following that step by step. And I also recommend in the tutorial, you'll see a link to this GitHub where you can open up and look at the source code. And that's also really helpful for today's workshop. Yes, thank you. Thank you, Janae. Yes. Let's see. So what are we going to be building today? Today, we'll be building an app that stores a number on the blockchain and only allows this number to be replaced by its square. For example, if we set a number to 3, the only way that number can be changed is if we submit the number 9. which is a square of 3. And these are all the steps we'll be taking to building a zkApp from scratch. We'll be installing the CLI, then we'll be creating a project, then we'll write the smart contract, we'll interact or test with the local blockchain, and then finally we'll deploy it to the Berkeley Testnet. So just wanted to remind you again, the CLI, I mentioned it back in previous slides, it's what makes it super easy to write zk smart contracts. It provides project scaffolding and also includes SnarkyJS, the TypeScript library that we'll be using to work with writing smart contracts. And so that's what we'll be doing right now. We'll be downloading the CLI. To do that, please open up your terminal and enter in npm install zkApp CLI. And once it's downloaded, you'll have all the zk commands available on your system. GitHub link. Let me go find that. Actually, should be. Oh, good. Yeah, and then I'll also post the command you need to put in your terminal. Let's see. Oh, actually, it's at the top. Let me add it. It should take probably like a minute for everything to download. And once it's downloaded, enter in your first zk command, zk-s version, and check to make sure that you're on 0.8.1. So if you download the CLI previously, it might have been a little bit older, just because we've been like updating it the last few weeks pretty regularly. Is everyone good? And if you type in zk-s help, you can take a look and see what all the commands are, see all the commands that comes with the CLI. We can create a new project with zk project. We can use zk file, which will create a new file for us, which we'll see later on. There's also some example projects that you can play around with if you type in zk example. Okay, we're done with step 1, super easy. Next, we're going to create a project. Let's see. So to create a project, we're going to use the second zk command, which is zk project, and we're going to name it 01 hello world. So let me give that a try too. I will do it along with everyone. Let's see. So zk project. And then you'll be asked a series of questions, whether we want to have a UI project along with it. For this particular workshop, we'll put down none. And then we'll be setting up a project. Oh, I'll share the slides with everyone here, actually. Let me see if I can do that. Okay, cool. So if you see a success, that means the project was successfully created. And so the next step is let's go enter our project. CD hello world. Whoops, hold on, make sure it's there. And if you look at your folder, you see a bunch of files are created. We do presented. Okay, so we've done this part. And now let's take a look at the project structure real quickly. We'll be mainly working in 2 folders, the build folder and the source folder. The source folder is where all our TypeScript files or our smart contracts will be held. And then the build folder is where our JavaScript code after our TypeScript files are compiled will be held. Next, we need to prepare the project. So if you go back to the terminal, you have to remove, there were some built-in files that were included when we created a project. We're going to remove those and then create some new ones. So it'll be something like this. Let me go back. Also, how's the pace for everyone? Are there people following along? I'm just curious.
So after creating the zkApp folder hello world, is that supposed to, yeah, so I didn't get this when you do ls, right? I didn't get all the folders. So when I created the zk project command and then selected none, right? The setup project kind of failed for me. I got an error right, EP proto. I mean, let me just copy the error.
Yeah, can you copy it in the chat and then maybe we can dig into it. Is anyone else having an error like this? Or I also might recommend, let's see. Maybe checking ZK system as well and sharing what it says there. Interesting. Okay. We'll need to dive into this in the Q&A. But for now, maybe we can try to follow along and see what happens. If that's okay. All right, let's go back. So the next step is we need to remove some files that came with our project. So normally, if you didn't get any errors, it would be, you would have all this. And if you enter in your source folder, you would see there's an add file, a test file, index, interact. So we're going to remove add test file and interact. So so all that's left is index. We'll go back to the main folder, and now we're going to create some files, the square files. So oops. I don't know if there's a way to share both things. If anyone has suggestions on tools, let me know. ZK file source square. And it created two files, a square TypeScript file and a square test file. And then next we're going to create a main TypeScript file as well. You can see if we go back to our source folder, we have 3 brand new files here. Oh, sorry, these 3. How's everyone doing? It's okay. Let's see. Okay, let me go over. So yeah, I just went over, this is what the source folder looks like. And so we're done with creating a project, step 2. The next step is we're going to write our smart contract. Let me see if we can make this bigger. So at this point, I recommend, any questions?
Yeah, I just have one question. When I did zk file source/square, it created it, but it didn't create it in source. Not sure what happened there, if that happened to any. Oh, it created another source within. Okay, I see what happened. Never mind.
Okay, cool. Yes, sometimes you be careful which folder you're in when you're running that command. So if everyone's okay to move on, I recommend you open up your text editor, preferably VS Code. And I would open up the Hello World on VS Code. So it looks something like this. And the particular file we'll be writing our smart contract is in the square TypeScript file. And here's the overview of what our smart contract looks like. Super simple. It's just 22 lines of code. And it's broken down into an import statement at the top and then the smart contract class at the bottom. And I'll talk a little bit more about what's going on in both parts. So as you remember, a few slides back, I mentioned that all smart contracts on Mina are written in TypeScript. And that's thanks to a library called SnarkyJS. And so SnarkyJS takes all the magic out of writing ZK circuits and makes it super easy. And you can actually see like the whole reference guide for this library on Mina docs. There's tons of methods and classes, and new ones are being added or updated or refactored all the time. So definitely check it out. It's pretty updated. So at the top, we have our import statement, and that's where we get to work with SnarkyJS. It's important to have the statement here where we pull in all the classes we will need to write our smart contract. For example, the two I want to highlight is field type. That is the base data type that's used in SnarkyJS. Since we're not working with a regular program, we're working actually with a lot of math, it's ZK, we have to use something, we can't use things like strings or numbers. Instead, we're using something called fields. And so that's why that's one of the things that we have to import from SnarkyJS. The second class I wanted to emphasize here is smart contract class. And this is the class that's essential for writing smart contracts in the first place. Pretty much every ZK smart contract on Mina will have smart contract imported from SnarkyJS. So let's go back to the Square file. The first thing we'll do is we'll have to, let me just show you. Let's go back and let me find the. So earlier I recommended that you open up this particular GitHub link because this is where the source code can be found, the complete smart contract. And I would go into Square, the Square TypeScript file, and just copy this over and then paste it into VS Code. Let's see. So let's go here, Square. Yeah, so here's the import statement. This is what I just mentioned earlier. Just copy that in. You could type it one by one, but just for sake of time, we'll just copy and paste. The next step is we're going to be working with the smart contract class. And so I can also just copy this over here as well. But this is kind of the baseline structure for how all smart contracts will be written on Mina. They'll always have like export class, some name. It doesn't have to be Square. It could be like Apple extend smart contract. So this here would represent a smart contract called Apple. Okay. And something to note, actually, okay, the next part, we're going to start with creating a on-chain state called num. It's written here. Let's see. And copy that over. Just don't forget the @ sign. So what's happening here is we are creating an on-chain state, naming it num, that can take in a field element. And with Mina smart contracts, we can have up to 8 fields worth of on-chain state, and each one storing up to 32 bytes of arbitrary data. But in our simple smart contract, we're just going to have 1 field in this case. Okay. It'll be easier just for me to scroll down. Okay, here, the next part is we're going to set up, write a method that sets up the initial state of the smart contract on deployment. And so let's go do that here. You can just also copy this over. What's going on here is we're initializing this method initializes our smart contract when we first deploy it to Mina. And over here in this line, what we're doing is we're setting this particular state to 3. Are there any questions? Oh, there's some questions in the chat. Cool. Alysia is answering them. Our next step is, now that we have a method to set up the initial state, this is the fun method. Let me make it a little bit bigger. Let's see. So here in this method, we are creating the logic that the end users will be like, or the logic behind our smart contract, or what the end users will be doing with our smart contract. What's going on here is we're creating a method called update that takes in a field element. Actually, let's copy this over and then let's talk about it. So go back to GitHub and copy this in. Okay. Okay, so we're going to go through, well, actually, we don't need to go through every line by line, but the one thing that I think most people have questions about at this point is like, cool, we have this logic written here that takes in a number and checks to see if mul here means multiply, checks to see if this number here is equal to maybe two numbers multiplying by each other. But that's, okay, I'm going to too much detail, but basically how does Mina know that this is like okay, or that they can make some updates to classes? That's thanks to a method called assertions. And actually, Alysia, would you like to explain how this works?
Yeah, sure. So when you create a zk proof, you're creating some criteria constraint that the input has to pass to be considered a valid proof. So the assert statement is used for this. So in this particular example, the criteria that we have is in order for us to update the state in the smart contract, the number that is submitted to the smart contract has to be the square of that number. So if the number that's currently stored in the smart contract is 2, then the square of 2 is 4. So the only way that this transaction will work and we'll update the smart contract is if the person submitted the number 4. So the assert statement here is creating the criteria for the proof, and that is essentially a zk proof. Like, this is a very simplistic zk proof, but the input that the person submitted is then checked, verified to see if it is actually a correct one, and if it is the correct number, and that's where we're saying square assert equals current state multiplied by current state. So if the input that they submitted 4 is equal to the current state is currently 2 multiplied by 2, then a valid proof is generated. And once a proof is generated, then we can send this to the Mina blockchain. The Mina blockchain verifies that indeed this is a valid proof, and then we can update the state in the smart contract. So that is why we have the line square.assert equals. So as a developer, when you're thinking about building a zk proof, you are thinking about how do I define some constraint that would give me a valid proof when the user supplies their input. And the line above where it says this .norm.assert equals current state, the reason why we have this line here, it probably seems a bit weird. We just received the number from the smart contract, which says it's the current state. And then we're asserting equals that it is the current state. And I think that confused me as well. But the way that I understand this is that because Mina actually does the computation offline, meaning not on-chain, which is not like Ethereum. Ethereum does all the computation on-chain. Mina does it off-chain. We have to just make sure that the number that we have offline is equal to the number that's on the Mina blockchain. And once we verify that that's the case, then we can continue with the rest of the activity. So whenever you are creating a proof and you are retrieving a number from the smart contract, i.e. the state, you have to just make sure that the number that you have is the correct one, and then you can continue.
Thanks so much. That was the best explanation. Awesome. So at this point, we actually, what normally we would do is we would build a UI or a website that would interact with our smart contract. That's not part of the scope of today's workshop. Instead, we'll be writing a script that interacts with our smart contract. And if you're interested in actually building a website after this workshop, there is a link here you can click on, and it's a tutorial that'll teach you how to build a UI. And so in order for our script or UI to interact with our smart contract, we'll need to go back to our index file and create an entry point for our project. So let me go back to VS Code, and you can actually find that back here, index. You can just copy this over for now. Oh, this is a different file. Whoops, sorry. I already did this earlier. That is not it. Let's see. Actually, it is. 1 second. Whoops, it's this one. Okay, if you go to your index file, it probably would say add, because originally when we first created our project, we had a file there that was add, and it just automatically had this included. I just changed this to square. name of the smart contract. And then change this to square as well, and then save. Okay, cool. Everyone good so far? Okay. Cool, thank you. So just a quick recap. At this moment, we've written our smart contract code in our Square file, and then we also update our index file so that our Square smart contract can be accessible from either a UI or a script. Now the next step is to interact with the local blockchain, and usually you would do this if you were testing or, yeah, usually just testing. And for this part, I'm just going to go through this quite quickly because testing is also not the priority of today's workshop. But if you like to dig deeper into this, I recommend checking out the tutorials as well. There's so many on there that can go deeper into how everything works. But let's open up our main TypeScript file. And this is just an overview of what our script will look like, of how we would interact with our smart contract locally. As I mentioned, we won't go too deep into this, but I can generally give you an overview of how this works so that you know what's going on. So at the top, there is an import statement because we're working with SnarkyJS again. In the second half, we are setting up a local blockchain, and then we will actually deploy our smart contract in this section, and then we will interact with our smart contract at the end. Let's see. So actually go back to GitHub, and you can find everything already here. You can just copy this over and add it to your main file. And I'll go through a little bit. Let's see if there's something to mention about each section. Yeah, so as mentioned, there's an import statement at the top, just like with the Square smart contract. I mentioned that there is from lines 15 to 20, you're setting up a local blockchain, and yeah, you're gonna have a test account. Not that important to know this at this moment. And then finally, the next line will be actually deploying our smart contract. You can see like, yeah, there's a deploy method here. We need the private key. Yeah, just over here, what's going on is we're just deploying Square. And then the part that's most important is we are checking to see if we're able to interact with our smart contract. So in line 37, we are pulling in that initial on-chain state, figuring out what number is. And if you remember back in our smart contract, we set num to 3 as our initial state. So we should expect for this line, the console log line, we should get num equal to 3. And the following lines after that is we're just testing, we're sending transactions to test out, make sure the logic in our smart contract is working correctly. And the first transaction will be sending in the number 9. And so this should pass because 9 is a square of 3. But then we'll also send a second transaction, 75, and this should fail because 75 is not the square of 9. And there's some console log messages here too as well that'll like help us figure out what's going on. So let's run it. Let's go back to our terminal. Let me clear it. Make sure it's saved. So you're just going to enter npm run build and node. Let me copy this over. Anybody? Oh, it's actually also in the tutorial. Actually, it might be easier. Let me just show you how to do that. You can scroll down and copy this over. Here we are going to run. Okay, so this part seems to be working fine. The initial state is 3. And then we send a transaction 9 that should go through and the state will be updated to 9. Ignore this error message for now. And then the second transaction where we sent the number 72, that should have failed. So the state should still stay at 9. Oh, I guess we had a third transaction. I forgot to mention that. Let me take a look and see what that is. Oh, we tried 81. So that should pass. 81 is a square of 9. So go back to the terminal. Yeah, it should update to 81. And then that's it. So we are done. This is basically, we're done with working with our local blockchain. We tested it out and it seems like our smart contract is good to go. And so now we're ready to deploy to a live network. yeah, exciting. Let's see. So Berkeley is Mina's live public testnet. And right now, all zkApps are available on Berkeley. And we're right now in the final stages of testing, and it's going to be on mainnet soon. And so when that's available, we'll post an announcement about that. But it's super easy to deploy to Berkeley to testnet, and it'll be easy to deploy to mainnet as well, thanks to the CLI. And so all you need to do for getting your project or your zkApp ready for deployment is to create a config file. So go back to your terminal and enter in zkconfig. And you're going to want to follow these steps here. Oops. I should have put them both on the same slides. So you'll get a series of questions. You're going to enter in Berkeley this URL, which is linked to the testnet, and then enter in a fee. Let's do that. So actually, yeah, you can find all these instructions on the tutorial. Actually, it's tutorial 3, not 1. So go to tutorial 3, scroll down, and you can just copy. Oh, here it is. You can just copy everything over. The URL. Set the transaction fee to 0.1. Oh, it's good to see the word success. And the next step is we need to fund our Mina account. And there's already a URL pre-populated here. You can just copy that over, paste it in your browser, and then request. This is our Mina address associated with our particular zkApp. And we just request it. And this part will take about 3 minutes, so we're probably not likely to deploy, or maybe I'll deploy it like in a few minutes from now from the call. But assuming that we get our funds, so we're requesting the funds here, we can deploy. We'll just enter in zk deploy Berkeley, and then our smart contract will be deployed to a live testnet, which we can't do now because we haven't received the funds yet. But I'll do it in a little bit because I think we still have time. Yeah, so basically, we covered a lot today. We covered what is Mina. We covered what is zkApp, SnarkyJS. And we also went through a tutorial step by step. And for those of error messages, let's talk about that later. But yeah, you should be able to now create your own zkApp project. You can write a smart contract, you can test it, and you can even deploy it to a test network. Yeah. So the next steps are, yeah, continue to keep building, check out the tutorials, play around with the SnarkyJS library. We also have a program called zkIgnite, or Mina Foundation has a program called zkIgnite that you can apply for and build your own zkApp and also receive like funding for it. There's also a Discord channel that you can participate in where you can get help on any questions or error messages like this. More tutorials on our website. And then also happening, I think it's happening right now or like in 30 minutes from now, we have a week office hours for devs where you can just jump in, ask questions, or listen in on what other people's questions are. Also, just wanted to throw this in, O1 Labs is hiring for these roles. If you are interested or know anyone who would be good at this, check out this greenhouse link here. Yeah, and that concludes the most part of the workshop. And now we're in Q&A. Are there any questions at the moment? We can talk about questions. Thank you. Thanks for the applauses. We can talk about the tutorial. If I went through something too fast, feel free to interrupt. Ovia, yes.
Hi, Regina. Thank you for the wonderful session. I want to know, can you point me to some resources on how I can learn about Mina itself, like how the blockchain is formed, what's the consensus? And I'm getting the feeling that it's like it's not a purely permissionless blockchain. Am I right in saying that? Because you said that the Mina transactions are like constructed off chain and then just the proof is on chain. So I mean, where can I read about these things?
I think the best place to learn about that would be the Mina docs. Yeah, I think that's the
I
best.
guess
place
the
to learn.
docs are for the developers mainly. Like,
Mm.
I want to know more about the blockchain itself, the consensus.
Okay, let me think about it. Oh yes, there is a white paper. Yeah, there's also. Are you interested in learning how like the proof systems work? Because there's also
Yes.
some. Okay, we do have. Oh, Yanni, thank you. It seems like we have a page on protocol
And also,
architecture.
also when you say that the blockchain has fixed size of 22 KB, how would you exactly verify? How would you invoke a transaction, a function on a smart contract if the smart contract doesn't exist, only the proof exists?
Can you repeat the question? I don't think I know the answer to that, but can you repeat it again and I will find out.
Because you said the blockchain is just 22 KB, right?
Yes. Yeah.
So recursively, just the proof is just saved. So everybody on the network would just have that 22 KB of data, right? So
Yes.
if you had to invoke a function on the smart contract, nobody would really have a copy of the smart contract. Or is it like they maintain something locally and a proof is like appended to it or something? So I'm just figuring. I'm having trouble understanding how all of this works conceptually.
Yeah, I totally get that because I definitely was in that boat too, and I still feel like there's still more to learn, at least on my end. But yeah, the smart contract is not on. Nothing about the smart contract will be uploaded to the Mina network. All that's really being sent there is just the proof. You can see the transactions. You can see the on-chain state. Let's see if I can find. I guess this is not the best picture to explain what's going on behind the
So then,
scenes.
if it's all off chain, then is it centralized?
No, it's not centralized. Yeah, yeah, I wouldn't say it's central. It's still like everything. It's more, I would focus on it's private. Like your smart contract is on your own computer. It's not shared with anyone else. And the way for other people to access your zkApp is through a website. People can log onto the website, sign their transactions with their own Mina account, and yeah, you wouldn't be sharing the smart contract code with the world as maybe you would with other types of blockchains. Yeah, if you would like, oh, Alysia.
Hey, I just want to add to that offline computation. So if you remember the code for the smart contract, which is the example that we have here where we're updating the square. So that code is what the developer writes. And normally you would have a UI and you'd encapsulate the app and you'd store it somewhere. So if you store the application that you are running on Amazon Web Servers, like people do for many other decentralized apps, then yes, the app is stored centralized somewhere, but you can also decentralize the storage of the app by using something like IPFS. But every single app you implement or interact with on the blockchain right now, a lot of them are using some centralized servers for sending you the website or giving you permission to view the website. The decentralized nation, sorry?
Yeah, I got that. Even in Ethereum, it works that way. So the app should always have a some kind of so you kind of have to figure out what data you want to store on chain and what data is not really relevant on chain. You can use centralized Web2 architecture for that. But my question is this: there is some data that needs decentralized storage that has to be stored as you mentioned states on the smart contract somewhere. So where do those smart contracts live? How are you able to get that state value 3 if only 22 KB of data is actually stored on the blockchain?
So the smart contract code is not stored on the blockchain. So if you look in like the Ethereum, like Explorer, Etherscan, you will actually see smart contract code for like an RV smart contract. In this case, the actual code is not stored on chain. What is stored on chain is something called a verification key. And that key is created when you go through the deploy statement. So if you read up more in the documentation, it will talk about the fact that in your code, you create something called a prover function. The prover function is, for example, the update function that we have here for this square example. It then generates a proof. And then the generation of that proof, there's something called a verification key that is sent to the Mina blockchain. So whenever someone interacts with the app, let's say you have the app hosted on your local machine or on a server somewhere, someone interacts with the app, and what is actually sent to the blockchain is just the verification that, okay, this transaction was actually validated. So if the person submitted a number that wasn't the correct square, it wouldn't even be submitted to the Mina blockchain. So the decentralized nature that you're curious about has to do with how many people are running the nodes. That information I actually don't know, but that is how we talk about decentralization in this case. But the fact that the computation is running offline is not because it's permissioned, it's just because it makes it more efficient for Mina to A, process the computation, and B, also maintain the fixed storage size of 22 kilobytes.
Thank you, Alysia. Yeah, I guess I have to go through the docs to understand more about this. Thanks for sharing that.
You're welcome.
Francisco. I don't think we heard anything. You can also post in the channel your question. Yeah, let me know if you can post the question in the channel. Raisa.
Hi, can you hear me?
Yes.
Awesome. Yeah, my question is actually a little bit simpler. So if we wanted to go through this later on and we have questions, or we go further into the documentations and we have questions, but they're very preliminary, like entry questions, like beginner questions, what are the best ways of going about not getting like stuck, or like reaching out to people to figure out how to solve them and continue on our like learning journey with Mina?
That's a good question. Actually, I think all questions are great. There's no like beginner or bad questions or like dumb questions. Actually, just post them in probably our there's so many areas you can post in our Discord channels. There's a bunch of channels there we can ask questions about zkApps or how Mina works in general. There's also the weekly developer office hours that happens like every Wednesday. I think it's happening in 30 minutes or right now. It's either now or 30 minutes. I forgot. But yeah, it's happening. It happens 1 hour every Wednesday. And I definitely encourage you to jump into those calls, and you can ask your questions live and get like a live answer from the DevRel team at Mina Foundation or O1. Yeah, there's also a forum called Mina. Let's see, there's a Mina forum that you can also, I'll post a link there, but there's a Mina forum that you can post questions in as well. Yeah. Christine, feel free to add too if you have any suggestions on places where people can ask questions. Yeah. Or ping one of us on Telegram. Definitely open to that as well. Cool. Oh, Francisco's question is, would it be possible to use Mina for mobile? That is a good question. I think technically we can, but I don't know if it's been done yet. Yeah, but it's supposed to be. I know we're working on like something related to using the mobile browser and interacting with Mina that way. But I don't know where we are on that. I will ask around and let you know. Alysia. Thanks.
Whilst everyone is still here, I just want to talk about the fact that there is the Cohort 2 ZK Ignite program that launches soon, where you can explore your ideas for privacy-preserving applications and also get funded. So if you do have questions in general about, what are even good ideas for ZK proofs or ZK apps, check out their office hours, which I think, someone dropped in the link, which is really nice. Check out their Discord, but definitely keep yourself involved in the community because everyone is really helpful to get your questions answered. So by learning this in this presentation now, it might be a lot, but I promise you, if you just keep, diving deeper into it and start building, it will make a lot more sense, especially when you build an application for yourself or think of your own use case. Hi, Adrian.
Any questions about zkIgnite? We have Maddie on the call too. Emmanuel, do you have a question?
Oh, yeah, I do. I actually missed most of the session today, so I wanted to know if I can get the link to the recording.
Yes, it will be recorded and posted on YouTube pretty soon.
All right, thanks.
And then Christine also posted, she said, places to ask follow-up questions. She said, I like Discord. Yeah, join Discord. It's a great community. It's very active. Yeah, also it's just fun to search through Discord and see if your question's been asked, and you can hear different different responses or answers to it. Yeah, good question. Yeah, how was the session? How did everyone feel about the workshop? Did you like the format of it? We'd love to get feedback too if there's no other questions. Also, if anyone wants to talk about use cases, we can also talk about that here as well. If anyone has an idea for a zkApp or, yeah, this is also a good place to chat about it.
Hi. Can you hear me?
Yes.
Yeah, I really like the format. I like that, you were able to show the code here on the screen, but then there's also the tutorial that we could walk through as well. So I like having both of those resources. Overall, really, I've been reading a lot about it or seeing a lot about this topic, but it's nice to dive into it firsthand. So I appreciate that. I guess the only thing, like you said, with the use cases, it would be cool to see a walkthrough of the apps or just see it being used. And you have any resources to sample apps that have already been made or anything just to get a better idea of what it's like in the real world?
Yeah, sample. Alysia, you built a zkApp. Maybe we can show yours. There's also there's a website with a list of zkAppsformina.com. There's also a list there, but there's a bunch of, I guess there's still a bunch of zkApps being built, and they're quite early stages. Yeah, Christine, Maddie, if you guys know any good zkApps, I'd love to throw a link it in there for people to try out. Yeah. Yes, zkApps for Mina. Oh, and then Alysia's presentation.
Yeah, I have my presentation from when I participated in the Builders program. There are 2 apps here in this presentation, mine and someone else's, called Jen. And also I'll be dropping more videos and tutorials on my YouTube channel. There's one that I'll be dropping tomorrow about more about understanding a zk proof. So definitely check it out.
Yes. Can you put your link to your YouTube channel as well? I think that one's just for the video, and then people can check it out. Yes, there are also projects from zkIgnite Cohort 1 that you can check out. Yeah, maybe we should just pick 1 or 2. I feel like now we have a flood of zkApps. But yeah, if I come up or find a really good one, I'll send it over to you, Rashawn.
Thank you.
Okay. Well, I will stop recording. We can still hang around, but I feel like usually for live workshops, it feels a little bit different when we stop recording. But yeah, let me do that. And if anyone